Up until now, we were writing out the trigonometric functions, but we weren't solving for theta. So just want to talk about theta. This is the symbol theta up here. It's basically a circle with a line through it. But usually when people are writing it in math, you just sort of follow through with the circle. You can bring it around halfway and just bring the line right through. However you do it is fine. This is a Greek letter called theta, and it's often used to denote angles. So when you're talking about angles, you usually use theta. And it's usually common that x's and y's are for lengths, though you'll sometimes see it for angles as well, but theta is almost exclusively angles. So here's our theta here that we're trying to calculate. So this is talking about this angle right here, okay? So if you're trying to find what this angle is, and you're given two sides of the triangle, okay, you can use your trigonometric functions to solve for theta. So first thing I would do, any question that has to do with trigonometry, somewhere on my page, I'm going to write out my SOHCAHTOA. Okay, I'm going to write out my SOHCAHTOA. Then I'm going to look at the triangle and see what I'm given. Okay, I'm going to identify my angle, which is right here. Okay, and then see what sides I'm given. So I know this is the hypotenuse, because the hypotenuse is across the 90 degree, okay? And I know I do not have my hypotenuse. I do not know what my hypotenuse is. But I do know what the opposite side is, okay? I do know what the opposite side is. And I do know what the adjacent side is. Okay? So I know what the opposite side is, and I know what the adjacent side is. So I'm going to go over to my SOHCAHTOA and see which one has the two sides that I'm given. So for sine, I need my opposite and my hypotenuse. I know I don't have my hypotenuse, so I'm not going to use that. I don't have my hypotenuse again, so I'm not going to use cos. But I do have the opposite and the adjacent. So in this problem here, I'm going to use tan theta to figure it out. Okay? So you're given a triangle, you see what two sides you're given, you identify it, what are those two sides relative to this theta. In this case, I have my opposite and I have my adjacent. The trig function that uses opposite and adjacent is tan. Tan uses opposite and adjacent. The sine or the cos each would have needed the hypotenuse, here, but I don't know what the hypotenuse is. I could calculate the hypotenuse. You could put in Pythagorean's theorem and calculate it, but you don't need to. You can just use tan and use the two sides you're given. So let's do that. Tan theta, okay? Tan of theta equals the ratio of the opposite side over the adjacent side. So here's my theta. The opposite side is 2.1. The opposite side is 2.1. And the adjacent side is 1.2. Okay? So up until here, this is everything we've done so far. This is what we've done. I'm just going to make my theta look a little bit better. Okay. So once you have this, you can actually go through and calculate what tan is. We did that briefly before, but we're just going to emphasize and practice doing that today to make sure that's good. Okay? So this 2.1 over 1.2 is just a number. You can punch that into your calculator and just get a decimal number. Okay? You can do that, or you can leave it for now, just depending on what kind of calculator you have and how you want to put it in. Okay? If you look on your calculator, there will be a button. There will be a button usually right above your trigonometry functions that'll look like tan to the power of -1. Tan to the power of -1. Okay, take a moment, look on your calculator, see if you can find that button. So hopefully you can find that button. Now, when you're solving for theta, that is the angle itself. Theta is the angle. So we're going to have the angle theta equals, okay? So this is how you isolate the theta. The angle theta equals tan to the -1 of this ratio over here, 2.1 divided by 1.2. Okay, the ratio of the side lengths, the ratio of the sides of the opposite over the adjacent. So this you can just straight put into your calculator, okay? There are no shortcuts at this point to sort of learn and try to estimate or anything like that. You can just plug this straight in and you'll get an answer. Now, one important thing to keep in mind, on your calculators, there'll be a little icon up at the top that says either D or it says like DEG for degree, okay? You wanna make sure your calculator is in D or degree mode. If you see an R or RAD, okay, that means your calculator is in radians mode, okay? You're gonna get a different answer than what we're doing in here. Radians just means everything is in terms of pi, okay? Pi, so if you guys remember pi, and a full circle is 2 pi. And degrees is going to be, we're going to talk about, say, like 360 degrees. So you're going to be having answers in, a circle is going to be considered as 360 degrees. Radians considers a full circle as 2 pi, okay? So make sure your calculator is not in radians, because all we're going to work with here is degrees. Okay, so make sure it's in degrees. If it's not in degrees, put your hand up. I can help you change the mode. So everyone take a second, do this calculation, and let's make sure we know how to do it. All right, so theta that we're calculating is an angle, okay? It's the angle right here, okay? Here's our theta, this angle. This angle theta will equal the tan inverse of the ratio of the opposite over the adjacent sides. Tan to the negative 1 equals 2.1 divided by 1.2. So you can grab your calculator, and depending on your calculator, you're either going to do 2.1 divided by 1.2 equals, and then press your tan inverse button, or your calculator, you would press your tan inverse button and then put in these values, okay? So make sure you're familiar with the calculator you're going to be using and you know how to do it, okay? So when you put that into your calculator, what do you get as your answer? It's someone, oh, here I have it right in front of me right here. You're going to get theta equals 60.255, so we're just going to round that to 3. 60.3 degrees, okay? This is going to be 60.3 degrees. This is the angle right here in this triangle, okay? 60.3. All right, so if I asked you on a test, okay, here's my theta, what is this angle up here? What is this angle up here? You have two ways to figure this out. You have two ways to figure out the other angle. One is to do tan inverse again, except this time you're going to be switching. You're going to be switching these two, because it's going to be 1.2 over 2.1 tan inverse. The easiest way to figure out the third angle, okay, is you know this is a 90, and you just calculated this to be 60, okay? So if you want to figure out the remaining angle, you could do a triangle, the interior angles add up to 180. So you do 180 minus the theta you just calculated, which is 60.3, minus the 90. So you can plug that in, and what did you get? So you get 29.7 degrees for the remaining angle. Okay? So the one angle was 60.3, the other angle is 29.7, and the other angle is 90 degrees, which we know is right there. Okay? Let's do one more. Okay, so I want to give you guys a few minutes to try to do this one over here, okay? Let's call this one number 2. We have a right angle triangle. We again have a right angle triangle. One of the sides is 45. The other side is 61. Okay? Our theta is up here. Our theta is up here. And you're being asked to find what theta equals. So what is the angle that exists right here in this triangle? Okay? So take a second and see if you can figure it out. So the first thing I would do is write out my SOHCAHTOA, my SOHCAHTOA. Okay, I wrote out my SOHCAHTOA. So what am I given? Where is the hypotenuse? Where's the hypotenuse? And look and see, okay, the hypotenuse is the longest side across from the 90. This is my hypotenuse. I'm given it, okay? So I know what my hypotenuse is. Here's my theta. I do not know what the adjacent side is. The adjacent side is I don't know. I don't know what that is. So let me get rid of all the ones that need an adjacent. Cos needs an adjacent, so we're not going to be using that. Tan needs an adjacent, so we're not going to be using that. Sine needs the opposite and the hypotenuse. I have that. I have the opposite, and I have the hypotenuse. So sine is going to be the one that I use. Okay? So once you've identified that, you're going to write out your trigonometric function. So you're going to say sine of theta equals opposite, which is going to be 45, divided by my hypotenuse, which is going to be 61. Okay? Then you want to solve for theta. So solving for theta, the way you do that in trigonometry, just theta equals, it's going to be the sine inverse of this. Sine to the power of -1 of that exact same number over here. 45 divided by 61. You use sine inverse. We're going to use sine inverse when we want to calculate the angle. Okay? I'm going to say that again. We're going to use sine inverse. Okay? You're going to use sine inverse whenever you need to calculate an angle. So you'll always have theta equals sine inverse of the ratio of the sides. Okay? Sine inverse when you want to calculate an angle. So take a second and actually plug this into your calculator. What do you get theta to equal? Theta equals what? Theta equals what? So you plug this into your calculator. The calculator I have, I put this in exactly how it looks like on here. And I made sure my calculator was in degrees. And got 47.5 degrees. Okay? So that means this angle here, we calculated this angle. Calculated this angle to be, I'm just going to erase, to erase all this. We calculated this angle here, okay? We calculated this angle to be 45 degrees, okay? This was our theta, and we calculated it to be, why did I say 45? 47.5 degrees, okay? We calculated that angle, and now we know what that angle is. Okay, here's one for you to practice on your own. You have a right angle triangle. You have this side given to you, 120. This side here given to you, it's 100. And you're asked to calculate what this angle here is. So take a moment, see if you can calculate that. If you can, you have this down, and you should be good. So in this one, you're going to look at what you have. Hopefully we can go through this one quickly. This is my angle theta. I have my adjacent, and I have my hypotenuse. I have my adjacent, and I have my hypotenuse. So which ones of the SOHCAHTOA am I going to use? You got it. We're going to use our ka because we have our adjacent over a hypotenuse. So our cos of theta is going to equal our adjacent, which is 100, over 120. Solving for theta, theta will equal the cos inverse of 100 over 120. Plug that into your calculator and you get theta equals what? Theta equals, so you get theta to equal 33.6 degrees. All right, so that's using two of the sides of a triangle. Okay, if you're given two sides of a triangle and you're asked to find one of the angles, you can figure out which one of the trigonometric functions you're going to use. Am I going to use sine? Am I going to use cos? Or am I going to use tan? And once you've decided which one, based on what you were given, in this one, we were given adjacent and hypotenuse, so we're going to use adjacent and hypotenuse. In the previous ones, this one, we were given opposite and adjacent, so we use tan, because tan uses opposite and adjacent. In this one, we were asked to find this angle here, and we were given opposite and hypotenuse. So we used sine, because sine means opposite and hypotenuse.